Alright, we're ready to carry on with the example in design of experiments from the last video. And in this video I'm going to carry out the actual regression analysis in Excel. So first of all, you can see I've put in the three main effects, or the three factors if you like, and their interactions here. So I'm going to set up the contrast matrix with the coefficients here, and then I'm going to plug in the measurement results. And as you can see, I've made room for first run and the second run, which means that I've done replications in this case. So first of all, let's put in the levels. So we have a low level, high, low, high, low, high, low, high. And I believe that was 1, 2, 3, 4. Yes, that was 8. And here, low, low, high, high, low, low, high, high. And for this one, low, 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 high, 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 like that. That's just a systematic way of getting all the combinations. So in the first one, or let's take this one first, we have A at a high level, the enzyme concentration, the rest is at low level. In this one we have B at a high level. Here we have A and B at high level, so we call that AB. Here we have C at a high level, so we'll call it C, and so on. Like that. And this one up here we refer to as 1, so I'll put in the apostrophe here, like that. Then we need the interactions. So the AB interaction is equal to the product of the value of factor A and the value of factor B. And that goes all the way down. So I'll take a copy of this cell and copy it to the column here, like that. And for this interaction, we have the product of A and C values here. And we take a copy all the way down here. Oops. Like that. And for BC, it's the product of the B level and the C level. Like that. And finally, ABC is the product of A, B, and C. And we take a copy of that. Right. So the idea is now that you randomize, well, you want to go out and do all these combinations, measure the yield, the outcome, the response, if you like. But you shouldn't do it from the top. You should randomize the order, so that, let's just say that our randomization process turns out that we need to measure this combination first. So we go into the lab and we run the process at low enzyme concentration, high temperature, and high pH. And let's say that ended up giving a yield of 30%. And then the randomization process, and now it's very important that we just, I know it's tempting to continue with this combination because now we set the system up for this combination, so it's very tempting to just make another run and get the result here, but that's something you should avoid. You should randomize the order, which means that, let's say, out of the randomization process comes an order which requires that we take this measurement as the next one. And that happens to give us a yield of 68. And then we roll a die or whatever process we use to randomize the order, and out comes the next experiment, and that turned out to be this one, let's say, giving a yield of 55. And we continue like that until we have all the 16 measurements, but in randomized order. Like that. And now we need to rearrange a little bit because we need to set up the data so that Excel can perform the regression. So what I'll do is I'll make a copy of all the X values here and the interactions. I'll just make a copy of that, put it down here. And then I'll copy the second run here and put it down here so that it matches. So this is the number 4 here is the -1, -1, -1 combination. So it is here, so that's fine, like that. And now I have a column of y values and the columns of x values here that Excel needs in order to do the regression. Right, so let's do it. I go into data and data analysis. I choose regression here, and I choose the y values. I'll just choose the labels as well. This is not the best label I could choose, but oh well. Like that. And the x values, that's just my entire contrast matrix here, including the labels. Like that. So I tick this box here because I included the labels, and I want an output area. Yeah, let's just choose that one. And let's see what it gives us. So there's a lot of statistics here. For the moment, I'm just mostly interested in the coefficients here, and I'll translate the best I can. Here we have the intercept. The enzyme concentration has a coefficient of 20.5. And as you can see, the p-value is very low, so it's a significant effect. So indeed, the enzyme concentration does affect the yield. And it does so at this value here. So that means that if I increase the enzyme concentration by 1 molar, then the yield goes up 20.5. The temperature is also a significant factor here. It's smaller, but yet it's there and it's significant and it's positive. So that means increasing the temperature by 1 degree would increase the yield by 5.25. And in this case, we're talking percent because the yield is measured in percent. Also, the pH is at 5% significance level. It's just below that, so it's significant. And it's negative, which means that increasing the pH by 1 would lower the yield by 2.25. We also have some significant interactions here, AB, AC, but BC and ABC are not significant, as you can see here. So you wouldn't include those in the model. So let's write down the model. We'll just scroll over here. Oops. I guess that's all right. So the model is y equals 40.125 plus, and then we have a coefficient here, 20.5 times x1, where this is the enzyme concentration. And this is what we would call beta 1, this is beta 0. And then we have 5.25 times x2, where this is the temperature. And we have minus 2.25 times x3, this is the pH. And then we have interaction minus 6.625 times x1, x2. And we have interaction between the enzyme concentration and the pH, minus 4.875 x1, x3, and the rest is insignificant, so we'll leave that out. This is what we would call beta 2, beta 3, beta 1, 2, and beta 1, 3. These are, of course, these beta values are slopes, as you may know. And what does a slope actually mean? That means that if you're here and you want to take one step to the right along this axis here, then your function increases by whatever slope your model has in that direction. So let's say we're dealing with the x2 direction, so it's the temperature. Increasing the temperature by 1 would make the yield go up by 5.25. Sorry. So we're measuring the yield here. In the book, we talk about the effect of, say, factor B, so that's the temperature. Now the effect is defined as the change in y, in the y value, or the increase in the y value as factor B goes from low to high. So when we increase our temperature from the low level to the high level, and I think in our case we were talking about 20 degrees to 35 degrees or something like that. So increasing the factor from low to high would give us a yield change. And how much would the yield change? Well, that would change twice as much, because now we're taking 2 steps. We're actually going from, well, excuse me for my drawing here, but we're going from level -1 to 1, plus 1. Let's just call it plus 1. That's actually 2 steps, right? 1, 2. So the effect of my factor B here is 2 times, in this case, beta 2. So there's this relationship between the slope and the effect. The effect, in general, is equal to the 2 times the slope. And the slope is what we have in the model. The effect is what we talk about in the design of experiments.